Hi, in this video we are going to discuss metallic bond. This is the electrostatic force between the metal's ions, which are the cations, and the valence electrons of that metals. Here the valence electrons act like a glue which hold the metal's ion together and make a crystal. Valence electrons are free, they keep moving. So we said that these are the mobile electrons, while on the other hand the metal cations are the stationary. As we know that these are the metals which have low ionization energy. So having low ionization energy, metals can lose valence electrons easily. For example, we say that sodium is a metal. This has one valence electrons. This lose one valence electron and form monocation. While on the other hand, magnesium has two valence electrons. Lose these two valence electrons and form cation. Here, these are the mobile electrons which are free, and these are the cations which are fixed at the positions. These mobile electrons and cation develop the electrostatic force and make metallic compounds. There is a theory which is electron sea or gas theory which explains the metallic compounds or metallic bond very nicely. According to this theory, these are the metals ions which are immersed in the sea of electrons which are flowing. Here, these are the metals. These metals lose their valence electrons. In case of sodium, there is one valence electron. Every metal lose one valence electron in this way and form cations. Now, here metallic ions, which are the cation, and their valence electron develop electrostatic force, which are the metallic bonds. And these are the mobile electrons which keep moving. So we can say that these are the delocalized electrons. And these are the metals ions which are the cation which are immersed in the sea of electrons. These are the cations which are stationary or at fixed position, and these are the electrons which are the mobile or free and keep moving. So in this way, mobile electrons or the cation form metal crystal or lattice. And here these are the mobile electrons which conduct the electricity, which this theory have explained very well. There is another theory which is the band theory. This based on molecular orbital theory also explains the conduction property of metals. According to this theory, as in molecular orbital theory, atomic orbitals overlap and form antibonding molecular orbital or bonding orbitals. Atomic orbitals form conduction band, just like antibonding molecular orbitals which have higher energy, and valence bond, like bonding molecular orbitals. Oh, these are the bonding molecular orbitals which form valence bond which have lower energy. For example, in case of the metals which have conduction as well as the valence bond which overlap, here the conduction band which conduct the electricity have also electrons. Electrons from the valence bond move to the conduction band. And in case of the semiconductor, there is a little bit gap between valence bond or conduction band. So, when we heat, the electron jump from the valence band to the conduction band which conduct the electricity, and after that semiconductor become conductor. And in case of insulators, there is a big gap between valence band and conduction band. Here valence band has electron and conduction band is empty. And being big gap, electrons cannot jump to the conduction band. And when the conduction band is empty, so there is no conduction of electricity. Let us now we discuss some factors which make one metal stronger than other. Numbers of mobile electrons or the charge on cations make the metallic bond stronger, as the mobile electrons acts like a glue and hold the cations together and make metallic bonds stronger. For example, this is sodium, which has one valence electrons lose that electron and form cation. Magnesium lose two electrons and form cation, and aluminum lose three electron and form cation. So here we can say that as the number of electrons increase, the bond strength increase. Here this is the aluminum which has stronger metallic bond. Size also affect the metallic bond strength. Smaller size cations have greater electrostatic force or metallic bond strength. As the number of electrons increase, charge increase, size decrease, and the strength increase. For example, in case of size, lithium and cesium. Here, the size of lithium is smaller, so lithium have greater metallic bond strength as compared to cesium. When we see in the periods, this is size will decrease. So as the size decrease from left to right, bond strength increase. And in the group, when we move from top to bottom, size of the metals increase. And as the size increase, the metallic bond strength decrease. Metallic structure or packing of metallic atoms also affect the bond strength. Metallic atoms pack or arrange in three ways, which are body-centered cubic, face-centered cubic, and hexagonal close packing. These are the unit cells which repeat and form the metal crystal or lattice, and explain the arrangement or packing of metallic atoms. This is the body-centered cubic unit cell. This has 8 atoms at the corner and 1 atom at the body center. This is face-centered cubic unit cell. This has 8 atoms at the corner and 6 atoms at the center of 6 face. And this is hexagonal close packing unit cell, which has 6 plus 6 atoms at the corners. There are 3 atoms at the center and 2 atoms at 2 faces. In body-centered cubic unit cell, there are 2 atoms. One is being counted from 8 corners which are shared by 8 other unit cells, and one is the body-centered atom. Here, each atom is surrounded by 8 other atoms. So, this unit cell has coordination number 8. In body-centered cubic, there are 4 atoms in one unit cell, as one is being counted from 8 corners, and there are 3 atoms which are being counted from 6 faces, as each face is shared by other 2 unit cells. And in hexagonal close packing unit cell, there are 6 atoms. 2 atoms are being counted from 12 corners. 3 atoms are at the center and 2 atoms are at the face center. So there are 6 atoms. And in case of face-centered cubic unit cell and hexagonal close packing unit cell, there is coordination number 12. Sodium, lithium, etc. have body-centered cubic unit cell. Zinc, copper, gold, etc. These metals have face-centered cubic unit cell. Beryllium, magnesium, etc. have hexagonal close packing. And here face-centered cubic and hexagonal close packing have greater bonding strength as compared to body-centered cubic. This is because face-centered cubic or hexagonal close packing have occupied 74% spaces or having the greater coordination number. In face-centered cubic, atoms form 3 types of layer, and in hexagonal close packing, atoms form 2 types of layer. For example, these are the 2 layers of atoms which create 2 types of spaces. The first space is created by first layer, and there are also spaces which are created by second layer. Now in face-centered cubics, the atoms of the third layer occupy the spaces which are created by first layer, and in this way face-centered cubic form 3 types of layer which are A, B, C, and these again repeat. And in hexagonal close packing, the atoms of the third layer occupy the spaces which are created by the layer 2. Here the atoms of the third layer are at exact position as the atoms of the first layer. So this type of packing form 2 types of layer which we represent A, B, which repeat again and again, which we can also represent in this way. So there are 2 types of the layer. Let us now we discuss some properties of metallic compound. Metals are conductor. Metals conduct heat plus electricity. This is because there are free electrons which conduct heat and electricity. Metals are malleable. We can turn the metals into flat sheets. Metals are ductile. We can turn the metals into wire. This property is known as ductile. Metals have shining surface when we cut the metals. This is because here these are the mobile electrons in the metallic structure which absorb the light or the sunlight and are being excited. And when the excited electrons come back, they release energy in the form of light. In this way, they have shining surface. And metals have photoelectric and thermonic effect. As we heat the metal's wire, these wire release electrons or emit electrons. Thanks for watching and please comment if you have any question.